This is the first KCS talk for this semester. And I'm the speaker for this first talk here. Welcome here. I hope that more people will show up later. It's 12 now, so should we start? All right. This is a big topic. I have quite a few slides, so I cannot spend too much time on each single slide. Okay? So, well, except two slides where we have videos. So forgive me if I didn't spend enough time on a single slide here. So this is my talk here for this semester. What is AI? And what is going to happen next, right? So artificial intelligence, a concept formed 73 years ago, and the term defined 67 years ago, got explosive growth only recent. Okay. How recent? 11 years, 80 years, 6 years, or just 1 year? Well, that depends on how you consider where is the most critical point in the development of modern day AI. Okay, and you can answer this question at the end of the talk. All right, but the AI era is finally here. The generative AI era is upon us. The iPhone moment, if you will, okay, said Jason Wong. Okay. So are you ready for the AI era? Okay. Well, I consider this person, Jason Wong, okay, the luckiest guy on earth. The luckiest guy on earth. Okay. He is the CEO and co-founder of Nvidia. Nvidia has 3 founders. He's one of them, okay? All right, we'll take a look of this person more, okay, later. But first of all, let's take a look of a video. Okay. The name of the video is Start Shooting. Person should keep a low profile, never show off. Okay. Never show off. The question is, did this ever happen? Did this ever happen? This never happened. Okay. Even if it happened, it would be considered as a national security information. It wouldn't release this information. How could our great leader lost the competition to Mr. Putin, right? So this is just a result of some AI war. Right? And another reason I want to show you this video is AI and graphics are separate. Okay? Graphics needs AI, and AI needs graphics. Say it again. Jensen Huang. Okay. So, if you want to do AI, you need to know how to do graphics. And the other direction is true as well. Okay. So the topics that will be covered today are first, how was AI defined, and then how was the AI field developed and what is the current situation, and then finally, what is going to happen next. Okay? So we'll start with how was AI defined first. Okay? What is AI? What is AI? The concept AI was formed 73 years ago in a paper written by, I consider, the greatest scientist from the last century. The greatest. There's only one greatest scientist from the last century, Alan Turing, right? And this is the name of the paper, Computing Machinery and Intelligence, published in the journal Mind in 1950, all right? And in this paper, okay, the famous Turing test was presented, okay? If a machine can start a dialogue with a human being by intelligence, okay, and the human being will mistakenly take the machine, no, it also as a human being, then we say, or he says that machine is intelligent. Okay? The so-called Turing test. Okay? All right, and also presented in this paper is the following question, very important question. Can a machine think? And I interpret it as what? Can human being build a machine that can think? You don't have to answer the question now. You answer the question at the end of the talk, all right? And there's yet another definition of artificial intelligence. It was given by Marvin Minsky, okay, one of the founding fathers of AI and the 1969 Turing Award winner. Okay. The definition given by him was the science of making machine do things that would require intelligence if done by man or, of course, we, right? We. Okay. So, Marvin Minsky's definition of AI seems, to be broad, right? Compared with Alan Turing's definition. Seems, but I think they're equivalent. Okay? But I again ask a question here. Is Alan Turing's concept a subset of this definition? I hope this is not because of the video I just showed you. Okay. For those of you who came in late, you missed the very important piece of deep. Okay. The dart shooting deep. Very interesting. Okay. So I think it's connected. Minsky's definition covers all the cognitive functions of human mind. Therefore, we can say that artificial intelligence is a machine's ability to perform the cognitive functions of human mind. Yet, there is another definition, but before we go to that definition, okay, here's the question. Why was machine intelligence named artificial intelligence? It was because the so-called Dartmouth Conference, okay, in August of 1956, a 2-month conference was held at Dartmouth College. Now we call it Dartmouth Conference, right? And the purpose of this conference, remember it's a 2-month conference, is to discuss a topic. Okay? How can human beings, or how to use machines to mimic human learning and the other aspects of human intelligence. Okay. This conference is important in the following sense. First, it marked the birth of AI field. So you can consider 1956 as the first year of AI. And the second thing is that the name artificial intelligence was coined at the conference. Okay? They don't name it machine intelligence. From that point on, we name it, we follow those people, okay, such as John McCarthy, Mark Minsky, Claude Shannon, Alan Newell, Herbert Simon, all famous names in the AI field. Okay? And the third thing is a vision was set out and a roadmap was laid out for AI research by the participants, those people, all right? And also the Turing test was developed. What does it mean? Okay? The Turing test, of course, no. You think a machine is intelligent if the machine can talk to people and talk to a person and the person would think, no, that's not a machine, but a human being. Okay? But now they formally said that in order to pass this test, this conversation has to be at least 5 minutes long. 5 minutes, right? So, and yet, like I said, there's another definition for AI. This is given by Herbert Simon. Okay? He is a mathematician and the 1978 Nobel Prize winner and the 1975 Turing Award winner. He thinks intelligence is the manipulation of what? Symbols, right? And the most primitive symbols corresponding to physical objects. Okay? This definition makes sense because we can think abstractly, right? When you add 3 dogs to 6 dogs, you don't put them together. You simply just add 3 to 6 to get 9, right? But this definition is only popular with researchers who use symbolic method to develop AI algorithms. So you don't have to worry about this definition at all if you don't like it, right? So in general, we could say, what is AI? AI is a machine's ability to what? To learn things, to acquire and accumulate knowledge, to think, to understand things through what? Through thought, experience, and the senses, and eventually, to what? To develop or to create or synthesize new ideas based on what? Based on its experience and knowledge. We'll reinvent AI shortly, but for now, I think that this is what you should think what AI is, right? So then, milestones in the history of AI, okay? It has been 73 years now. Or I'm sorry, since Dartmouth Conference, 67 years, okay? So these are the important milestones. Okay? Of course, you know Dartmouth Conference now. And the second milestone is the development of the so-called perceptron architecture, and then the AI boom, and then the AI winter, okay, including the development of expert system, okay, and then the modern machine learning era is started with what? Development of natural language processing algorithms and computer vision algorithms, okay, followed by big data concept. I consider big data a concept actually only. And then, importantly, deep learning, followed by LLM, and then finally, GAI. We'll go through each of these. Don't worry. So, the second important milestone is what? The development of perceptron, and followed by what? Followed by AI boom, and then followed by AI winter. What is perceptron? Perceptron is an artificial neural network architecture developed by psychologist Frank Rosenberg in 1958, 2 years after Dartmouth's conference. Okay. This is an important milestone. Why? Because with this architecture here, algorithms can be developed to mimic human intelligence. Mimic means what? You can learn from the experience. You can improve performance through those, learning, results. Okay, and this is a breakthrough in AI because what? Because practical implementation of AI is possible. Okay. Note this word, implementation is possible. But it has not been really used in real life yet. Okay? So because of this, okay, AI boom started. Okay? AI boom, because you have something that you can base on or you can use to develop real AI algorithms. Okay? So AI boom, and this AI boom lasted for quite a while, almost 20 years. Unfortunately, perceptron architecture has limitations. What is the limitation? Perceptron is a binary classifier, but you cannot classify complex data. Most of the time, it can only deal with linear order data. It cannot handle nonlinear tree structures, for instance. So because of this problem, people started to look at different aspects, okay, or approaches, such as symbolic reasoning and natural language processing. Okay, so new programming languages such as Lisp, such as Prolog, and global positioning system, and this system here. This is actually the earliest version of Chat. Oh, okay. You can talk to a machine. This system here. Of course, very sharp, very simple conversation. All right. So the fact is, because perceptron has problems, therefore, any AI project, okay, couldn't develop or couldn't reach their objectives or couldn't deliver their promises, okay, because of the problems with the perceptron architecture, okay. Therefore, fundings, were cut, okay. People became despondent, disillusioned, and because of funding cuts, okay, many projects, were forced to stop, and people, leave this area, okay, leave this area. So eventually, AI winter came. It's about, the end of 70s. Okay? I think the fundamental problem here is that AI has two parts, training and prediction. Okay? For both parts here, for those parts, the AI systems developed, they always use a passive mode. I call it slave mode. Okay? They don't do things on their own. They only do things, they only do what they were told to do, okay? Like a slave, okay? This is not good. This is not good. Okay? Even the expert system developed later, are still, working in such a mode. We need what? We need an active mode or master mode, meaning that the AI system can work on its, the AI system can work on its own, can make its own decision, not just do things, doing whatever they are told to do, right? Even including the so-called expert system. What's an expert system? An expert system is composed of two parts, knowledge-based and inference engine, okay? Knowledge-based and inference engine. Using what? Using techniques such as induction, deduction, abduction to drive things. All right. And these systems here mark the turning point in AI history. Why? Because now you have a system that really used in what? Really used in real life. Okay? Before we have this, we have architecture that you can, implement your concept, but those things cannot be used in real life. Here, now you have a system that can be used in real life, even though they are still working in what? Testing. This is the problem. Expert systems rely on what? Structured data and rule-based logic. Rule-based logic means you do things according to the given rule, not on your own. Right? They couldn't handle unstructured data. Okay? They couldn't handle even Simon unstructured data. Okay? So they couldn't handle unstructured data such as what? Natural language tests or images, right? So people start to what? To develop algorithms that can handle natural language or can recognize images, meaning algorithms in the computer vision area. So in the beginning of the 1990s, research AI started to what? To pick up again, right? Mainly working on natural language processing and the computer vision. Okay? And this is the so-called, I call it machine learning era. Okay? Machine learning era. So beginning in early 1990s, researchers began to what? Use statistical and optimization methods to learn patterns and the features directly from data. Now, patterns and features could be from text, not only images, right? Rather than relying on predefined rules. Okay? So we start to change from passive mode to what? Master mode or active mode, right? And this approach, known as machine learning, allowed for what? Allowed for more accurate and flexible models for natural language processing and visual computing. I'll tell you what. And then the so-called machine learning era started. Okay. So what is machine learning? What is real machine learning? Machine learning, basically, this is an umbrella term. It covers all the algorithms that solve problems by helping machines discover their own algorithms without telling them what to do. I'll tell you what this means. Okay? It means the machine or the machine can learn from data and then can make predictions based on the data themselves. Okay? Of course, this is the so-called training part. Use data annotation process. Okay? Basically, is to mark those components or special areas of, for instance, an image to teach what this thing is to a machine, right? And actually, even though that machine learning started in the 1990s, but actually the term was coined a long time ago. It was coined by this person, Arthur Samuel, an employee of IBM. This term was coined actually back in 1959, all right? So, here is the basic, not basic, here is a very intuitive concept of the so-called training process. You have to teach the machine. Well, given this thing, what is this? Is this a piece of cloud or something? Well, you have to tell the system, or this thing here has 12 tires. It has a cab, it has what? Cargo container, and it has what? Gas tank. Such a thing is called a cargo truck. Such a thing is called a cargo truck, right? And a cargo truck could also just have what? 8 tires, sorry, 4 tires, okay? A cab, a cargo container, and a gas tank. This is also a cargo container, all right? Or with how many tires? 10 tires. A cab, a cargo container, and a gas tank. This is also a cargo truck, okay? For instance, things like this. And then, if an image like this is given, okay, the system has to decide what is this, okay? So first, it has to find characters of this thing here, and then make a decision or make a prediction based on his knowledge from the previous training experience. So this thing has 10 tires. It has what? It has, again, a cab and a cargo container, 2 gas tanks. Not just one, 2 gas tanks. So what is this? The machine has to make prediction, okay? We hope that the machine can make a prediction. Say, this is also a cargo truck. Cargo truck. If the machine can make such a prediction, of course, then it's very possible the machine can make its own prediction based on its experience or knowledge from the training part, okay, from the training part. So this is the so-called machine learning, all right? Very basic concept. Very basic concept. Okay, problems with machine learning algorithms. The volume and the complexity of data that is now being generated, too vast for humans to reasonably reckon with, okay? Especially if you want to make good prediction, you have to be trained on very large data set. Okay? You must have a very broad knowledge base. Okay? And the question is how broad, right? And it has also increased the potential of machine learning. Okay? The question is also the need for what most powerful computation support. Okay? The training part, okay, that's just 3 pictures 5 pictures. Could be millions, million of pictures, or even trillion pictures. Ordinary CPU cannot handle this in real time or quasi real time. So you need powerful computing support, preferably parallel computing. All right, and the rise of big data. This is a concept, I think. I consider it a concept, okay? Because first of all, what does big mean? The term big here has 3 attributes, okay, or 3 things to consider. Volume, velocity, variety, okay? And for volume, it's either trillion or quadrillion, 2 to the 40 bytes, or 2 to the 50 bytes. Very large amount. Okay? For the velocity attribute, you have to be able to generate and process those data in almost either real time or quasi real time. Okay? And the variety aspect is diverse types of data that are generated, okay? Including not just structure, but also unstructured, semi-structured data. Okay? So what does this mean? First of all, data sets for the training part of machine learning algorithm should be as big as possible, so that when you try to make a prediction, your prediction would be what? Would be close to what? To the true answer. Okay. In order to achieve such a point, you must have a very, very big knowledge base. Okay. But before the emergence of what? Of big data, most machine learning systems were based on what? Were based on handcrafted rules. So limiting the complexity and the variability of the data sets. Okay? And this concept, big data here, provided what? Access to massive amount of data. Okay? Provides a direction, and consider the direction. Okay? Where to get those massive amount of data. All right. So machine learning can access big data sets for training purpose once we have this so-called big data concept. Then the advent of deep learning and LLM. Okay? Deep learning and LLM. Okay? It started in 2012. Okay? 2 graduate students of Jeffrey Hinton at University of Toronto used the GPU-based neural network to win a prestigious 2012 AI competition called what? ImageNet, by identifying photo images, much lower error rate than competitors. Remember 2012, right? And the important thing here is Jeffrey Hinton and his students showed to the world that the deep learning models method running on a GPU-based neural network are 20 times faster than old or traditional machine learning models or methods. Therefore, starting from 2012, people started to what? To switch to deep learning method in models because of the advantage of speed. And the critical point here is that deep learning models method requires strong computing power support, preferably parallel computing. So we're gradually getting into our real focus here, okay, current situation. I have to speed up. It should be mentioned that the attention mechanism based on large language models, okay, if you need a reference, here it is, okay, made deep learning models even more powerful. A large language model, okay, is a trained deep learning model. Okay. It can understand, can generate text in a human-like fashion. Okay. And such a function is supported by something called a transformer model. It's actually a very large model, okay, behind the scene. Okay, behind the scene. Again, this is, we don't have time to cover this. Again, okay, well, remember that what? Remember that the parallel computing power support for deep learning models is very critical. And now with the inclusion of what? With the inclusion of large language models, that support is even more critical. Remember, even more critical now, all right? So now, back to the luckiest guy on earth. Jason Huang, CEO and co-founder of Nvidia. Why we call it the luckiest guy on earth? First of all, Nvidia reinvented graphics by bringing AI and real-time ray tracing to what? The GPU, 2018. Before, in order to generate, a video like this, it would take what, 30 some hours. Okay? But now, you can do it in real time, with Nvidia's GPUs, right? The AI should also be reinvented. Okay? You need to remember two words: mimic and big. Mimic and big. AI system. It's not just software, also hardware, okay? That can what? Can mimic human intelligence and the behaviors in real time, That's the most important requirement. Okay? Through what? Through training on big data sets, okay? Big in the sense of what? Big data sets. Trillion or quadrillion, okay? So here's the current situation. Some people think that the AI should actually just be defined as what? Nvidia. Why? A little history. Go back to 2015, okay? Three people. Elon Musk, the maverick guy. Sam Altman and Jason Huang, they met. Okay. The purpose is to form a company to what? To build the most powerful AI machine in the world. An AI company was formed. The company is called OpenAI, right? In that year, okay, also shortly after the meeting, Nvidia gave what? Nvidia gave a supercomputer built with 10,000 Nvidia's A100 chips to OpenAI for free. Nothing. You don't have to pay me nothing. And of course, then OpenAI started to work to develop the most powerful AI machine, the so-called most powerful machine in the world. And this maverick guy, Elon Musk, okay, resigned from OpenAI in 2018. I don't know the reason. He does crazy things. By the way, if you are too conservative, you wouldn't be able to change the world. All right, so then there was this big explosion. October 2012. No, I'm sorry, October 2022. The generative AI ChatGPT was launched, okay, by OpenAI, okay, by OpenAI. And you know the rest of the story. Okay. So ChatGPT was developed or launched in 2022, right? And you know that generative AI is what? It's a system that can what? That can generate new data or content, okay, in response to a prompt, okay? And the new data or content is similar to data it was trained on. This shows you the importance of training model. And in such a data or content could be what? Could it be image? Could be a piece of text, could be a piece of music, or even a piece of video, like the one I showed you at the beginning. The dart shooting game. Okay. The point is, no matter how knowledgeable GAI is, if we cannot respond prompts in a timely way, real time or quasi-real time, nobody would use it because people are spoiled. They have no patience at all. Okay? So you must have what? You must have a platform, or you must have a infrastructure that can provide that kind of computing power. Okay? Now remember that only last year, 2022, the market value of Nvidia was just 150 billion. In less than a year, actually, May this year, okay, the value of Nvidia jumped from 150 billion to what? To $1 trillion. $1 trillion. Okay? Why? Why? Well, ChatGPT, okay, is not just software, deep learning model-based machine learning software. You also have to look at this part, the infrastructure or the platform, super machine built with 10,000 Nvidia's A100 chips, right? It's this part that made real-time what? Real-time ChatGPT possible. It's actually this part. Okay? This part is not, this part is, is known to most of the people, okay? But only a few people can make what? Can make the software working in real time. It's this part. So all of a sudden, it appears that if you want to build an AI system, you need to get what? You need to get AI chips from Nvidia. So everybody rushed to Nvidia to get AI chips. What are AI chips? They're just GPUs with some AI enhancement. So basically, they're still GPUs. And this market is completely dominated by what? By Nvidia. By Nvidia. So if you want to get AI chips, you have to go to Nvidia. Say, please, right? So, without the infrastructure provided by Nvidia, modern GI is not possible. That is why some people say AI is nothing but Nvidia. That's why they say AI is Nvidia, all right? So here's the question. Did Jesse Huang and Nvidia foresee the emergence of ChatGPT and the big success when they gave that supercomputer to OpenGI in 2015? I don't know. The only thing I know is that without AI chips, You cannot do AI now, okay? And that market is dominated by Nvidia. So what's going to happen next? This talk might a little bit longer than 50 minutes. Okay? First, we will migrate to a post-PC era. And I call the PAIC era. PAIC means personal, PC means, of course, personal computer. PAIC means personal AI computer, or simply PIC era, all right? Why? Because every PC, I believe, will have a built-in GI system, such as, ChatGPT. Only that GI will be even more powerful. Okay? And Google will no longer be needed because your PIC will do the search for you, all right? And with GAI, anybody can be a programmer. You don't have to know how to, write a program in C or C++ or Python, okay? Because your PIC, your personal AI computer will do the writing for you. Okay? Will write the code for you. As long as you can tell the computer, the PIC, what you need to do. Right? So, why? But you have to tell you have to know, you have to tell the algorithm, you have to tell the computer the algorithm or the task. And so different employment concept, okay, different employment concept. Anything that's done with a fixed procedure or a fixed way of thinking can be replaced by AI. AI has mostly been doing cognition-related tasks, less on perception-related tasks. We don't have time to cover this part, okay? Jobs that will be replaced by AI. AI can do all the natural language processing type of work. Can do speech recognition, can do computer vision. So we don't need the people in these areas anymore. Actually, most CS computers are no longer hiring faculty members in computer vision and natural language processing, right? Jobs that are safe in the next 10 years. Okay? Jobs rely on personal experience. Okay? So this will be safe. And jobs related to entities, okay, such as doctors, nurses, their jobs will still be safe. Industries that cannot be accessed by big data, such as jobs with high requirement for innovation, okay, such as my job, okay, such as yours, will still be safe, or Kevin's job, or Tom's job, okay? In a different way to run business. A bigger market capitalization company run by a small number of people will become common in the future. Okay? With proper equipment, a single person can run a 1,000-acre farm. But now with proper AI support, a single person can run a company whose revenue is, say, 10 million or even 1,000 million, or even bigger than that. Here is a simple example. Midjourney in San Francisco, it has only 11 employees, and yet the annual revenue of that company is what? $100 million. So it's no longer true in just farm. In the business world, it's true as well. Okay? Almost everything will be LLM based. Okay? LLM, of course, large language model. There will be an LLM, I believe, in front of almost everything. You don't see a receptionist anymore. You see something like this. But it can do much more than a receptionist. Okay? Human will become a new programming language. Okay? Remember that you don't need to know a programming language to write a program, okay? Because your IC will do it for you. Okay? As long as you can communicate with your IC, then you are a programmer. So if a dog can communicate with the IC, then a dog can be what? A new programming language as well, right? So this is the end of my talk. Before you go, let me give you some information on salaries at OpenAI. Salary range from 325,000 to 1,370,000. Okay. Of course, this belongs to the CEO. Okay. And the median salary is $925,000. Okay. Not 15,000. I'm sorry, not 150 or 180. It's $975,000. All right. The base salary is $300,000, but this part plus stock option, and the median value of stock option is $625,000. That's why the median salary is $925,000. So if you want to make big money, you know where to get it. Right? So, are you ready for the AI era? This is what you should know about AI, what you should do to get yourself prepared for an AI era. Okay. Remember, human being is self-programming language. Any questions? And we have references. This is the reference for large language model, the so-called attention mechanism-based approach. Any questions? It's a little bit longer than our usual talk, but this is where the question later. Oh.
Yeah, the presentation was fantastic. So I have one question. In your the graph where you told the evolution of AI from the old part to the open ChatGPT, I have one question, that is ChatGPT initially when it came out, it started with GPT 3.5, which used Nvidia A100 GPUs, 1024 A100 GPUs.
But let me stop you for 1 second. Some people say 10,000, and some people say 1024 AI chips. But that's not the point.
Yeah. Okay. That's not the point. My question is, just before that, the GPT, DALL-E came into picture, but it seems that DALL-E didn't gain, or DALL-E 2 didn't gain as much as importance, as much as popularity as ChatGPT did. Why is that? Both used V100s.
I don't know the real reason, okay? But one thing I can tell you is that when Nvidia was first formed, for the first several years, the company almost bankrupt. So you cannot always be successful. You have to try different possibilities. That's the only thing I can tell you. And remember, you have to be a crazy guy to be able to change the world. If you are too conservative, you have no way to change the world. And I'm a conservative guy, so I don't have such kind of capability. But you see a crazy guy here. This person should be able to change the world someday. And it is changing the world actually now. Yes?
Given the current big hype and focus on generative AI and large language models, do you think, or what do you think that says about possible emergence of artificial general intelligence?
Artificial general intelligence.
Yes, AGI. And do you think that AGI would be LLM based? And maybe how quickly do you think that sort of thing would emerge given the current focus?
I don't know the answer to your question. Yeah. Like your general AI. No, I don't know the answer. If I can get, Jeffrey Hinton to give a talk here, he might be able to answer your question. Jeffrey Hinton, the father of deep learning. We'd like to hear people like him give a talk. All right. Then please sign in and enjoy the generosity, the food, the pizza, and the drinks. Okay. And our next talk is 2 weeks from today. That talk will be given by Angus. I don't know how to pronounce his last name, but he's here. And stand up, show people. So he will be the speaker of our next talk. Okay. You're very excited.